I do want to ask that in order to justify my travel expenses, you'll at least follow me on Twitter. Um, yeah, that was a shameless. Yeah. So a little bit about me. I'm the co-founder and CTO of PureSec, an Israeli company based of Tel Aviv, doing serverless security. I've been involved in the application security industry since the end of the 90s. There's at least one person here that knows it's true, that knows me for 20 years at least. I was responsible for the research of the world's first web application firewall, back then called AppShield, IBM AppScan, and later on Akamai Kona Cloud Security products. Authored about now 22 patents in the field of application security, and there's a list of some of the research papers that I published. I think the most recent one from not related to serverless from 2 years ago was the HTTP2 fingerprinting project that we had. I'm also, more importantly, the founder and guitarist of an Israeli art rock noise band called Pits, without the, just Pits. You can listen to our music if you can suffer, yeah. So, I'll be honest, if we want to talk about serverless security and be thorough, that will take a lot more than the 30 minutes that I have. So I had to pick and choose a few important key topics. I do urge you all to go and download the Serverless Security Top 12 guide that we just published together with the Cloud Security Alliance a few days ago. So we will cover serverless security in a nutshell, and we'll talk about a few of the risks and pitfalls, and also if the demo gods will be with us, we'll do some live hacking on stage. And from that, that's obviously not to scare you, we learn about how to overcome these problems. And then a few action items. Now, serverless security, in the first 3 years of modern day serverless, people thought it's not your servers, it's not your problem, somebody else is managing security, but today we know that's not quite true. There's still a lot that you have to do. However, things dramatically improved. I actually tweeted about that a few weeks ago, where I believe that serverless is actually going to be a boost to application security or to cyber security. I hope that's going to be the case. Now, when we're talking about serverless security, you have to remember the cloud shared responsibility model, where the cloud provider is responsible for everything under the serverless runtime. So from the locations, the guards, the locks, the physical security, all the way up to the virtual machine, the containers, or the micro VM, or whatever it is that runs your application. And you are still responsible for the application layer, and that's very, very important to remember. That means obviously the functions, the identities, the cloud configuration. And this is also where we like to concentrate. And this is when we're talking about serverless security, we're actually talking about the blue part. You can just take it for granted that the cloud provider is doing their part of the deal. Now, how much is the cloud provider offloading from you? And this is a Twitter, like a photo op. So if you look at infrastructure as a service, or EC2 or instances, you weren't supposed to. Those in the back, you're not really supposed to see the list. It's just gibberish. But that's a long list of security tasks or chores that you have to do in order to secure your infrastructure and your application. And it's basically some stuff I took off of PCI and other security standards. You can see that when you adopt infrastructure as a service, the cloud provider is pretty much responsible for 8%, 10%. It doesn't really matter. The number doesn't matter, but for a very small portion of the tasks. And when you go serverless, that pretty much balances. Actually, the cloud provider is responsible for a bit more than you are. So that's very reassuring, assuming that the cloud provider knows what to do, and they do. If we look at recent history, the time to patch, vulnerabilities, and there have been some really nasty vulnerabilities lately where we saw the cloud provider patch within 24 hours, which I'm guessing that most organizations will still take years to patch all their servers. So from that perspective, I think serverless is a huge boost to security and brings a very interesting promise to the cybersecurity landscape. So you all know how serverless works, but I do need to have the I guess, slide here. Usually the developer will deploy code to the repository, then deploy to the cloud. You have a bunch of event sources. I think last I heard for AWS was 47 different event sources, unless I can be corrected, and those will trigger your code, which will run, usually interact with some other cloud services or RESTful APIs or GraphQL APIs, and hopefully if everything works well, will generate some output. Looking at the attack surfaces, if that's how we look at serverless, and again, I'm not listing all of the attack surfaces. I'm definitely not talking about the risks. I'm just talking about how can an attacker even gain access to your functions. So we see a few paths. The attacker will be the orange hoodie guy or girl. The first is through the event data itself. So event triggers the function, brings with it data. If the event is HTTP triggered, that's very easy to understand. Parameters, cookies, headers, we've all been there. If we're talking about other types of cloud native events like SNS or SQS or Dynamo or blob storage, then each of those brings with it a different set of data values, elements, with different encoding schemes. I've seen, I think, Kinesis comes with zip encoding, right? Not if I'm correct, yeah. Okay, so each of those can carry with it. Okay, one of them had, yeah, so base64, even better. And so each of those fields can be controlled by, not each, but some of those fields can be controlled by the user and in turn by the attacker and can be used to push malicious data in. So that's one way to manipulate the function. The second way is by deploying functions out of band. How do you do that? History tells us that attackers usually do that through either phishing or cross-site scripting, stealing credentials or session tokens, as we will see in a second in the demo, and then using those to, potentially using those to deploy code out of band. Another path through the code is by injecting a dependency with some malicious data. So I think the most recent example I have is there was an NPM package that was poisoned to contain Bitcoin mining malware recently. So imagine that you're using that in a serverless function, and we all do use open source packages. In like an on-prem scenario, it's very easy to detect that. You're in control, you see the behavior, you can sniff the network. In a serverless environment, it's a bit harder than that. So it's not a serverless specific problem, but it is harder to spot when you're running in someone else's environment. And last but not least, if the function during execution actually interacts with the cloud resource, like an S3 bucket or blob storage or one of those, and for some miraculous reason that is publicly open, like that never happened before, then obviously you can manipulate the business logic as well. And what can an attacker actually achieve? Anything that you can think of from the world of application security, compromising data, abusing the business logic, leaking secrets, even denial of service, as we will see in a second. Two more slides before the fun part. First of all, why am I here talking to you about serverless security? What's different, actually, with serverless security? And if you look at the traditional application security solutions that we all know and love, web application firewalls, runtime application self-protection, I can keep on cursing, they all require some sort of infrastructure that you will deploy them on. So either a server or a network. If we're talking about a web application firewall, it needs to be somewhere between the user and the application. It needs to inspect layer 7 traffic, right? And in serverless, by definition, as the application owner, you don't control the environment. So you can't deploy anything. With one, I think, exception, you can use a cloud WAF, like the AWS WAF or Akamai's or Incapsula. But that would work only for the HTTP traffic triggers. Anything else, that will not work. And even then, I'm pretty skeptic about web application firewalls' abilities when it comes to analyzing and detecting attacks inside more sophisticated traffic like WebSockets or MQTT or whatever it is that goes through there. So those traditional security solutions are out of the question, which obviously is a problem. I also have a nice diagram for that. You take an application today in order to give it like a 360 airtight security, you would install an endpoint prevention on the host to make sure that the application is not misbehaving, and then an IPS on the network, obviously a web security gateway to inspect outbound traffic from your app, next-gen firewall, and obviously a web application firewall on layer 7, and you put all of that on your infrastructure, and you ship the app, and it's all secure. But when you go serverless, you break up the app into functions, you deploy the functions to the cloud, which is basically another word to saying the internet, and then they're just out there. And just as your users can access those functions and trigger them, so can malicious actors. And the only thing that stands between them and a successful exploit is how well you wrote the code and how well you configured and how strict were your IAM roles and things that we will talk about now. So let's start with IAM. And I had this joke where I wanted to say that I think the acronym is like the sound that the developer makes when they figure out that they don't understand anything about IAM. So it's like IAM, but never mind. It's a good thing. I'll skip it in the next presentation. So you're my guinea pig on this joke. OK, when you work with IAM in serverless, and I apologize, I'm talking in AWS lingo here all the time, you need to make sure that these functions run with the least required privileges. And that's actually very interesting because the model, at least the AWS IAM roles and permissions model is very granular and very powerful. This is something that's allowing you to do things that you could never do in monolithic applications, like to take a function and make sure that it has the least required privileges it needs in order to do its job, and we'll see that in a second. As we can see here, the developer is using dynamo.putItem. However, there's the human factor here, and that could be because of lack of awareness, laziness, future-proofing your code, many different reasons. I keep asking people, why do they do that? Eventually, what we see is developer using wildcard permissions or over excessive permissions instead of wildcards. And by the way, just a quick quiz. Can anyone actually name and spell the right permission for dynamo.putItem? Really? OK. It's putItem with camel casing. Never mind. You need to go back and do some homework. Now, what happens if you do use Dynamo wildcard? You're basically granting the function the ability to do all of these things. As you can see, and you will see in the demo, that can pretty quickly escalate to something that you don't want happening. And yeah, those are among the most common issues that we are seeing. And I think I actually blogged about it a few months ago. I see those as bulkheads in a ship, where good IAM permissions can actually save your life in case somebody manages to exploit a single function. And then the least privileged strict IAM role is actually serving as something that contains the damage. And you will see that soon. So a quick story, and this is real. Meet Caleb. And Caleb and I go, I think, 20 years back, and Caleb came up with this website called lambdashell.com. It's still live. You can all play with it. He wanted people to try to do damage to his AWS account. So he created a Lambda function that actually runs shellcode. It's basically remote code execution right there and then and there, right? They're handing us a remote code execution. By all, if you look at it in any type of other application, that would be considered game over for the attacker, right, for the application. And he offered a $1,000 bounty, which actually reminds me that I never got my money back. I'm still waiting for it. So when I saw this, I decided, OK, this is something that can really benefit everyone. Let's try to give it our best shot. And so I started looking at what's in there, what is it doing. And I noticed that if I can run shell commands, I can basically run the env command and get the environment variables, which we all know contain some really fun things. Specifically, the 3 tokens that are used here, the session token and the secret key, and I forgot the last one. And so what I did is I took these 3 environment variables, the session tokens, and I set them on my local Mac desktop. So now I could actually run and impersonate the Lambda function and use its role and run commands. And I was like, OK, let's see if this is actually working. So I ran the command, and then I ran STS to see what is my caller identity. And I saw that I am now running as the Lambda function, which is really fun because I don't have to use Caleb's ugly user interface. I can do everything from my own shell. So with that, I was like feeling terrific. Yeah. I said, OK, I'm Lambda now. Let's see what I can do with the permissions. He probably left a lot of bad permissions. And so I tried the first thing to list the other functions in the account, and I got a permission denied. And then I tried to get the function goat, I got permission denied. And then I tried to do some to list buckets, and I got a permission denied. And then I said, OK, Caleb isn't that stupid. He figured out that he needs to protect and limit the IAM role. And so I was a bit bummed for, I think, 2 days. And then suddenly I said, OK, maybe there's an S3 bucket. There's always an S3 bucket. And when I do a web app and I host it on Amazon, then I use a bucket with the name of the actual domain as the name of the bucket. So I tried to check whether there is a bucket using the head bucket command. And I got no reply. Like, I got an empty line. And so I was like, OK, does an empty line means there is a bucket or there isn't a bucket? So I tried a different one here, and I got a 404. And then we were back in business. So the next thing I did was to list the object in Caleb's bucket. And then I saw a long list of buckets. And then I said, OK, I wonder if I can do something with these buckets. So I said, let's see if I have some kind of write permissions, maybe try to delete something. So I'll delete the index.html, right? Wrong. Big mistake. 2 hours later, I'm getting a call from Caleb. The site is down. I'm in, I think it was in Las Vegas during Black Hat. The site was down for a full 5 days, which was terrific for me because none of our competitors was capable of approaching the site. I should, in theory, receive the $1,000. We did win the challenge. So, getting back to IAM permissions, my best recommendation is to always adopt a role per function model. That's your path to success here. If you're using SAM, and I do recommend that, use manage policies. Now, even there, you can make a mistake. Obviously, you can use a full admin god permission for Dynamo, which is not what I'm trying to teach you here. Or you can use a crude policy, which is what you should be doing. Obviously, use a custom role per function. There's a plugin that does that. I actually love it. And PureSec also offers a free open source tool. I can demonstrate it after that actually scans your code and generates a least privilege role for you. So it's a huge time saver. Next, app DOS. How are we with time, Jeremy? They have a break after that. I can keep talking. I need 5 minutes for the demo and like 5 slides. OK. Meet Corey Quinn. Yeah, he's the one on the left. And Corey and I were talking before our last reInvent, and Corey said, you know what? You talk a lot about serverless security. Let's see what you're really worth. If you manage to do some damage to my account, and Corey's running the mailing list, I'll install PureSec, and I will blog about you, and I'll make sure that you get a spike that people will see from outer space in traffic. So I said, OK. But he did warn me there's nothing really interesting there. It's just like a sign up for a mailing list, and that's it. So we started digging, and he actually gave us the code, which is not fair, but that's how it was. He gave us the code, and we looked at the code, and we saw that he was using a library, I think it's called SendGrid, to send emails, and then in SendGrid, he was supposed to create an email object from the email he's getting from the user, and that parses emails. And when I see a parser, I instantly think, OK, this is going to be interesting. So that parser, by the way, is eventually using the Python's email package. I should probably contact them as well, which supports this RFC 28 22 kind of formats. You all know that, right? Where there's the real name and the thingy. So seeing this, I decided, okay, what? And obviously going through the code, I can figure out that the regular expression is not that efficient. And if my email will look like this, and that's a very legitimate email, I should say 100 kilobyte of this, then it will take a few moments to run. So instead of a few milliseconds, it actually takes 2 seconds. And that's it. So where's the serverless security issue here, right? If you post this 1,000 times to Corey's, well, not now anymore, to Corey's sign-up page, it will go down. And surprisingly, it was down for an additional 5 minutes. So using this Mac with really not a lot of resources and 1,000 HTTP requests, we managed to take his registration form offline for 5 minutes. And I have a terrific movie of that to prove it. It took a few months for Corey to figure out what he wants to do. Eventually, he blogged about it, and we got the traffic spike. Yeah. I don't have a lot of time, so I'm skipping one more. You can read about that at the PureSec blog. I really want to do the live demo here. So live demo, and please pray that this will work. I'm just kidding. As long as US East 1 is up, we should be okay. Okay? Or if the screen starts working. So actually, I need this slide. So we have here, hopefully if you will, I'm really pushing it. So. Okay, so what we have here is an HR application that's 100% serverless running on AWS Lambda. The way it works, the candidate for the job sends an email with a PDF containing a CV. That gets handled by the Amazon Simple Email Service, triggers through an Amazon SNS topic Lambda. The purpose of Lambda in life is to extract the attachment, turn the PDF into plain text, run candidate textual qualification analysis, store the results in Dynamo, expose a web interface here. I know if PureSec's not going to succeed, I have a new business going. So that was a joke. Let's see how we can actually abuse that. So, as I promised, this is an email-based application, right? There's no fancy interface. If you need me to do this better for the back row, terrific. So what we'll do is we'll type an email. I'll call myself John Smith, because there's nothing more yeah. And let's type something like my CV is attached. And I'll attach the CV, so excuse me for a moment. The CV is a completely standard, non-malicious. There's no malware whatsoever, like a fake computer science CV. We'll attach that, and we'll send it. Now what happens in the background is, and again, no infrastructure, which is amazing. This is serverless at its best moment. Lambda is waking up, taking the email, turning the PDF into plain text, runs the candidate qualification analysis, pushes it all to Dynamo database, exposes the web interface, sends us a receipt, and all of that with the cold start. I think it's very impressive. I can show you the HR application that actually is protected by Cognito as well. And we can invite the person to an interview, etc. So, for the sake of the story, let's assume that we didn't qualify, we didn't get accepted to the job, and now we want to get our revenge. And the revenge will come in the form of data leakage. We'll leak the entire database of candidate sensitive information. How do we do that? Okay, so if this was a web-based app, I would probably launch SQL Map or some other tool and start fuzzing every parameter in every form, etc. Right? But we're not that lucky. We are dealing with an email, and I'm not going to try to take down Amazon's hosted email service, right? Or managed email service. So we need a different approach. Bless you. How do we do that? So we need to somehow sense whether the application is vulnerable to our attack. And how do we do that? First of all, I'm going to choose an attack entry point. I need somewhere to fuzz. So we'll go with the file name. And This is safe to assume that a system like that would take the file name maybe when it's, use the file name when it's copying something from one place to another or extracting the CV. And so we'll start with the file name. And what we'll do is we'll change the file name. Instead of John Smith, we'll type John semicolon. And then sleep 5000 hash. Again, 20 years ago when I was making demos, I would use like a debug prints coming back, and people would tell me eventually that's not really, that's not how people actually program today. You don't really expect, like if we send an email with this attachment, I don't expect to get an email back with the stack trace in it. You'd need a really, really stupid developer to do that, right? So I need a different technique, and the technique is a time-based probe. What am I doing? Assuming something is using the file name inside the shell interpreter environment, semicolon will hopefully split the command and will run sleep 5000. I chose 5000 because it's very obvious that the system will time out. And in case of Lambda, it's going to not reply with the receipt email that I got earlier. So that's sort of like a time-based probe. It's a very common technique that's been going on in the web security world for the past 20 years. So we don't have 5,000 seconds, so you'll have to trust me that nothing is going to come back. Now we know that we can abuse the file name as the input vector. But what do we do next? We know nothing about the application. We don't really know if it's serverless or not at this point, right? So we need to gain access to the source code and turn it from a black box engagement to something that's more easily hackable. So how do we do that? Again, same trick. This time, the file name is not going to be so short as semicolon sleep. I need something longer. So I'm hosting that on pastebin. And what I want to do is basically run some Python code that extracts the name of the function, the handler, and then opens that handler and pours the source code back into a reply email. Now, it's one thing to have it hosted on pastebin. How do I get Lambda to actually run it? Lambda or any other app. Very similar to how we've done with the semicolon sleep. I'll zoom in a second. Instead of semicolon sleep, semicolon this really ugly long string, which is basically to silently curl out from Lambda, fetch the payload from pastebin, and then pipe it into Python 3 child process. And yes, that will work. Obviously, .pdf at the end because it's a file name. Now you understand why people tell you to actually validate the file name, right? And that will take about 10 or 15 seconds, and we will get the source code back. And then we'll go to our next trick. Yeah. So by the way, I crafted the payload in a way that the function still runs. So if you now look in CloudWatch, CloudTrail, or App Insights, or whatever it is, you won't see any kind of violation. We just exfiltrated the source code of the function without triggering any kind of, violating any kind of security policy, and obviously, it's not going to show up anywhere. And so we got the original response, and we got the source code. Now, I don't expect you to read source code in email, which, no, that's not why I want Slack, which is why I have it here as well with syntax coloring. You're welcome. So let's see what's going on here. The developer is defining some table name, taking that from an environment variable. OK, better practice than actually embedding the table name there. We see it's a DynamoDB client. The function gets the event, reads the SNS message, extracts the payload, gets the file name. Security conscious developer actually checking and validating that the file name ends with a .pdf, so not entirely clueless. And then, the clueless part, the developer is embedding the file name from the attachment directly into the command that was predefined, which, by the way, the developer is using a very common CLI tool called PDF2Text, which does exactly that. And then when we type semicolon sleep, we basically split the developer's original intention into two. the first command, and everything after the semicolon was controlled by us, and we could run whatever we want, like get the source code and send it, off to somewhere. And then the developer is using the dynamo.put item to insert the data into Dynamo. And this is now the table that we are after and we want to exfiltrate. How do we do that? Again, the first mistake was trusting user input coming from the attachment name, from the SNS, and the email. The second problem is obviously going to be the bad permissions. So let's see how do we abuse that. Again, I'm going to use pastebin for this. Slightly different URL. What my payload is going to do is going to create a DynamoDB client and then run dynamo.scan. It's like a select everything from the Dynamo table and giving it the table name that I don't really know. I'm just reusing code reuse, using the environment variable that the developer defined and then dumping everything into the email. So will this work? Let's see. Very similar payload for the ones in the back row, different pastebin URL, okay? You know it's going to work, right? Yeah. 10 or 15 seconds from now, we'll get the entire table. Now, this is really cool. If you've ever done pen testing to a web app and you've done SQL injection or blind SQL injection, you know it takes thousands of HTTP requests to exfiltrate each and every character in the table. You have to do it like in a binary search kind of thing. Is it above or below some value? And that takes a long time and is very, very, very noisy. And it's easy to spot that in logs. However, we just exfiltrated the entire table in 3 HTTP requests, or email requests actually. And if we now go to CloudWatch or CloudTrail, you're not going to see any violation. Again, the problem here was the problem that a developer caused. Looking at the serverless YAML file, the developer made the classic mistake of assigning the function a role that has all the Dynamo actions, while in reality, all we needed was the put item. So now you understand and think about what would happen if we would fix this. The function would still have a remote code execution, but the only thing the attacker would be able to do is to insert items into the table, which is not as bad as what we've just done. I can live with that. How much? That's it? I'm wrapping up. So, 4 action items I had to choose. Did everyone follow me on Twitter? I'll check. I know exactly how many followers I had before this. So, not the Q&A. Multi-screen thing is really confusing. Okay, first of all, download and read the 12 most critical risks. Last year it was 10. This year we go all the way up to 12. A lot more to read. There's a good bunch of people here in the crowd that actually helped. So I want to obviously thank everybody, and they're mentioned there. Serverless Goat is an app that we pushed with a single click of a button inside the AWS app repo. You can install it. It's completely safe, and you can demonstrate your hacking skills to your colleagues and come out smart. And also teach your developers about secure development lifecycle. There's a library called Function Shield that is completely free. All you have to do is give us your email. Eric is here. Don't worry, we never use that for anything. I'm serious. It's a library that basically provides you 4 different, very basic behavioral protections for your Lambda functions or Google Cloud functions, like blocking outbound network connectivity and so forth. If you are one of the lucky ones that already downloaded it, you can attest to the fact that we never used your email for the wrong purposes. And last but not least, the least privileged IAM role generator, a command line interface, open source. You can download it. No strings attached. It will automatically generate an IAM role for you, so that's very helpful as well. Thank you very much for having me. Thanks.